Okay, so this lesson is on electrical energy. Okay, and what you guys need to know is the relationship between electrical energy, charge, and potential difference, voltage. Okay, um, I think it's really important to understand the concept first before the equation. So as a result, instead of looking at electrical energy first, I'm going to look at something called gravitational potential energy. Now we'll study this later on. You may have met this idea in KS3. So we've got certain things will have potential energy due to the height they're at, okay? So potential energy gravity, we would call it, or PEG for short, is the potential energy that something has due to its height, basically. But it's not just its height, it's its height in a gravitational field, okay? So we all live on planet Earth. Most of us do anyway. And planet Earth has its own gravitational field, okay? And we'll meet that idea later on, and you probably would have met this idea in KS3. Obviously, the higher that we go, the higher I raise this object, whatever this is, maybe a little ball or something like that, the higher I go with that, the more potential energy it would have. So you could imagine if I drop it from a small height, then it wouldn't have very much potential energy. But if I bring it much, much higher, if I bring it to the top of a cliff, top of the Burj Khalifa, say for example, then its potential energy, gravity, or its gravitational potential energy would increase, all because its height has changed. But like I said, it's not just the fact that it's got a height, it's a height in a gravitational field. If you were to remove that gravitational field for a moment, let's say you went into deep space, okay? If you go into deep space and I take that same ball and I went to the top of a hill, even though a hill wouldn't really exist in space, or if I just went up and up and up, and I dropped it from there, then the ball wouldn't fall because there'd be nothing pulling it down, okay? So you have to have that gravitational field, all right? So why am I talking about that? So let me come back over to my water analogy that we have always used for electricity, okay? So we had said that the charge itself was the individual H2O molecules. In other words, the individual water molecules that's falling out of the bottle. We said the current was the flow. You can see the flow coming out. But of course, the potential difference, the potential, is the amount of pressure that I put on, or it's basically the height difference. But again, not exactly a height difference. It has to be a height difference within some sort of a field. So in our analogy, the potential difference was a height difference in our gravitational field. So hopefully you're starting to see the link here now, okay? So without that gravitational field, we would never get the water to move in the first place, all right? So again, just going back then to gravitational potential energy, if you look at how it's calculated, gravitational potential energy is going to be the size of the mass times the gravitational field strength times the height that you are in that gravitational field, okay? So basically what we can do is kind of draw a bit of a parallel here between this and what is going to happen in electricity. So our electrical energy, okay, it's going to be something similar. We said that it was the individual charges themselves, the individual H2O molecules, and they would be analogous to the mass. In other words, the weight of something, okay? So the size of the individual charge itself, okay, times the potential difference, okay, the potential difference through which we're going to pass that charge. And if you think about the potential difference, that's really the height in a gravitational field, okay? And that is analogous. These two things combined is analogous to our potential difference phi, okay? So again, the electrical energy that a charge is going to carry is going to be the size of that charge times the potential difference that we're going to pass that charge through. Okay, that's going to be how we calculate electrical energy. It's an easy enough formula. I think as a concept, it's a little harder to understand. But if you try to understand it in terms of potential energy, I think it makes far more sense. You take a mass. If I raise that mass really, really high, then I get lots and lots of potential energy. Okay, but again, it has to be in a gravitational field with some height. Okay, those two things combined, the gravitational field and the height, are analogous. There's that word again, analogous. They are like the potential difference. Okay, this is where our formula for electrical energy is going to come from.